All right, so example 50 says, given that x is equal to arc sine t, y is equal to t squared plus 2t plus 1, we're to show that d2y by dx squared is equal to minus 2 into 2t into 2t squared plus t plus 1. All right, so I'm just double checking to ensure that that is what is written there. All right. All right, it looks like that. So let's go. All right, so we have x is equal to sine inverse t. So dx by dt would be equal to 1 over the square root of 1 minus t squared. Y is equal to t squared plus 2t plus 1. So dy by dt would be equal to 2t plus 2. Now dy by dx would be equal to dy by dt multiplied by dt by dx. So this is 2t plus 2 over, so the reciprocal of this, so the reciprocal of that of dx by dt is the root of 1 minus t squared over 1. So if we want, we can say dy by dt is equal to 2t plus 2 multiplied by the root of 1 minus t squared. So we could write this as what? For one, let's write it as 2t plus 2 multiplied by 1 minus t squared raised to the 1/2 power. All right, so next we're asked to find d2y by dx squared. And everybody should remember that d2y by dx squared would be equal to you're going to differentiate dy by dx with respect to t. So this is dy by dx. You're going to differentiate it with respect to t. And then you're going to multiply by the reciprocal of dx by dt. So this is dt by dx. So the first thing we need to do is to differentiate dy by dt, which is, sorry, dy by dx. It should be dy by dx. This should be dy by dx. So let's differentiate dy by dx with respect to t. All right, so this is a product. So we're going to have to use the product rule, which says that if y is equal to uv, dy by dx would be equal to u dv by dx plus v du by dx. So we're going to differentiate, leave the first, which is 2t plus 2, leave the first, times, and we're going to differentiate the second. The half comes to the front. 1 minus t squared, sorry. 1 minus t squared. You're going to decrease the power by, you're going to decrease the power by 1. If you take away 1 from a half, you get minus a half. Multiplied by the differential of the inside function. The inside function is 1 minus t squared. When you differentiate that, you're going to get minus 2t. So that is leave the first, differentiate the second, plus differentiate the first. When you differentiate the first, you're going to get 2. Leave the second, 1 minus t squared raised to the half power. All right, so we could easily say that this 2 cancels this 2. And what would be left in here is, this is at the top, I'm going to have minus t into 2t plus 2. And down by the bottom, I have 1 minus t squared raised to the 1/2 power. And this is plus 2, 1 minus t squared raised to the 1/2 power. All right, let's erase this. And so let's finish up. We just need to simplify it to get it to look like what they had originally. So all we need to do is simplify. Bring the 2 at the front. You're going to factor out the 2t plus 2 to minus 2t, and we have t plus 1. The LCM is 1 minus t squared raised to the 1/2 power. Now this into this goes 1 times the numerator, give it back the numerator, plus this into this goes that, so it's going to be 2 times the numerator, 1 minus t squared to the 1/2 power, multiplied by 1 minus t squared to the 1/2 power. All right, if the base is the same, you add the indices. So I'm going to end up with minus 2t squared, minus 2t squared, minus, this would be what? Minus 2t squared minus 2t plus 2 into 1 minus t squared. Let's further simplify the top. We're going to have minus t squared minus 2t plus 2 minus 2t squared. So this is minus 4 t squared minus 2t plus 2. Factor out the 2. We get or factor out minus 2. We end up with 2t squared plus t minus 1. But this is supposed to be all over 1 minus t squared raised to the 1/2 power. All right, we have a problem. I'm going to pause. All right, so let's finish up. So to finish up now, what we have to turn the page. And something is written around there, so we're going to have to find space around here to do it. So what we have now is we just differentiate dy by dx with respect to t. We now need to multiply this by dt by dx. So let's change the ink just to, so what we basically have is just we have a space issue. So d2y by dx squared would be equal to this here. So we're not going to bother write it again. So it's this multiplied by dt by dx, and dt by dx is 1 over dx by dt. So what we have here is minus 2 into minus 2 into 2t squared plus t minus 1, and this is over, it's over 1 minus t squared raised to the 1/2 power, and we need to multiply it by the reciprocal of dx by dt. Dx by dt is this, so the reciprocal would be the square root of 1 minus t squared. If you understand anything, you should know that the numerator here and the denominator here, they are the same, so they cancel out each other. So our final answer is minus 2 into 2t squared plus t minus 1. And we were saved by a very brilliant student who I don't know exactly who it is because I wasn't paying attention when the person was speaking. But that is your answer, and that's where you would arrive at the answer.
Chanel.
That was Chanel, and she's so humble. She's keeping it all to herself. Chanel, you're correct. We should have, what we didn't do is that we didn't multiply by dt by dx. When we did, we come out with exactly what the examiner said that we should get.